Okay, students, thank you for coming here to see my third video of this solving LPP by simplex method. Okay, LPP by simplex method, we have to solve it here. Now, let me take that problem and I will solve it. Okay, then up to now what we have seen, step number 5 is the next simplex table. Next simplex cell table means we have to write the variable as it is. You see here x1, x2, s1, then s2, z, and then constant and basic variable. You draw the line like this, and this is another objective function line. Take a column like this to show the constants and basic variables. Yes. Now, as already we have done, what we have to do is that let me continue there. Okay. Yes. Now write all the values. Now equation number 2 you write as it is. Equation number 2 we have to write as it is, because here pivot element is there. That row you have to write as it is. Okay. So what is that? 1, 1, 1, 0, and then z is 0, then here constant is 1, and here s1. Yes. Now this is what the pivot element. Okay, I told you already that we have to make it here 0 by using this particular row or particular pivot element. Multiply this by 3, add with this, you will get 0 here. Do this operation for all the elements. Multiply this by 3, add with this. Multiply this 3 by add with this. Multiply this by 3, add with this. Multiply this 3, add with this. Multiply the by 3, add with this. That operation we have to do. Actually what we do there, multiply equation number, multiply the equation number 2, okay, by 3, then add with equation number 1, and you will get 0 here. That is new equation, that is equation number 4. Okay, you do that now. So multiply this by 3, add with this. What you will get? 3 minus 2, 1. Multiply this by 3 or this 3 by 3, add with this, 0. Multiply by this by 3, multiply by this by 3, add with this, you will get 3 here. Similarly, multiply by 3, add with it, you will get 0. Multiply by 3, add with this, 1. Multiply this by 3, add with this. Multiply this by 3, multiply this by 3, add with this. What you will get there? So 3 plus 1, you have to get 4. 3, actually here the constant is here is 0, not 1, 0. So multiply this by 3, add with this, you will get 3. Right. Now here we are make it 0 here. So So multiply this by minus 1, add with this, you will get 0 here. Multiply this by minus 1, add with this. Multiply this by minus 1, add with this. Multiply this minus 1, add this. Minus 1, add this. If you do so, you will get here 2, 0, minus 1, then 1, here 0, multiply by 3, add with, multiply this by minus 1, add with this, you will get 3 here, and here it is, you see here, which is in canonical form. S2 is canonical form, you will get S2 here, and here the canonical form is Z, but here the canonical form is X2, therefore here not S2, X2 we have to write here. So what you are getting there is not S2, but you will get as X2, because X2 is in canonical form. What operations we have get here? Multiply equation number 2 by minus 1, then add with equation number 3. You will get, this is equation number 5. Okay. Now this is the next simplex table. Okay, this is called next simplex table. We have, see here, the incoming variable is x2. That means the x2 has come in the canonical form, whereas already s1 was there, that then s1 is not in the canonical form. Am I correct? So bringing the canonical form is the prime aim of making the incoming variable. Okay, now what is this? Next step is what? You go back and see there, and the next step is that test for optimality. Step number 6. Okay, I told you that test for optimality. Test for optimality. Okay, now see here, yes, now see here in this particular row, Z row, our problem is maximization. Am I correct? Our problem is that of maximization. So see this Z row. In the Z row, all are positive entries. So Z row consists of, writing takes much time, consists of all positive. Am I correct? So all positive means what? The optimum is reached here. That is the meaning. Okay, if any negative number comes here, then optimum is not reached. But here all are positive in the Z row. Also it is a maximization problem. Am I correct? So the maximum is reached, which implies maximum is reached. Maximum is reached. Maximum is reached means what? Optimum is reached. That is the question. That's what we have to understand. Okay? Now, if that is the case, then what is the solution for us? That's what we have to understand. What is the solution? See here, this is called basic variable. Am I correct? So this is what the solution set. Okay. So step number 7, solution set. Solution set. Okay, solution set. So you see here, okay, this is what the basic value, this is the solution set. So x1 is equal to, x1 is not there, that equal to 0, and x2 value is 1, x2 value is 1, and s1 is not there, x1 value is 0, and s2 is not, is there? Yes, is equal to 3. So substituting these values in our objective function. Okay, what is our objective function? Okay, the objective function here is equal to, now objective function. Okay, now step 7. Now the objective function. Okay, what is the objective function? Objective function here is z equals 2x1 plus 2x1 plus 3x2, 3x2, okay, plus you have changed that objective function by adding this plus 0 into s1 plus 0 into s2. So substituting these values here, you will get maximum z is equal to 2 into, see there what we are getting. The value of x1 is 0, plus the value of x2 is what? 1. So it's equal to 3. So maximum is at is equal to 3, and this is what our optimum value. So sometimes it may be minimized, okay, but here optimum value, okay, we are getting optimum value. So sometimes they may ask you here as the minimization of z. So minimization or maximization, both we call it as optimization problems. Okay, in our problem the optimization is maximize z. So the value is, my optimum value is 3, and the solution set is this. See here, this is the solution set. x1 is equal to 0, x2 is equal to 1, s1 is equal to 0, s2 is equal to 0. So any variable which is not coming here, the basic variable, we have to take it as a 0. If any value is coming here, that value we have to take it to that value. So we are substituting, and last we are getting the answer, and that completes the whole problem. So thank you very much for listening part 1, part 2 and part 3 of the simplex problem solving. Thank you, my dear students and audience. Thank you.